Welcome, everyone. Thank you for joining us today for the launch of NIA's latest report called New Nuclear Project Development. My name is Judy Greenwald, and I'm the Executive Director of the Nuclear Innovation Alliance. This report is the latest in our work stream on catalyzing commitments to early mover nuclear energy projects. It dives into what energy project development entails and who can take on the project development role. Today, you'll hear a high-level overview from the new report's author, NIA Senior Fellow Steve Green, followed by perspectives from Craig Behlmer, who is the Chief Financial Officer of Oklo, and Jeff Miller, who's the Senior Director of Business Development at TerraPower. After our speakers provide their insights, we'll reserve the final 25 minutes for a Q&A session where you can ask questions to any or all of the speakers. Following Q&A, we'll wrap up with final thoughts and adjourn. As a little housekeeping rule, you're welcome to start asking questions now by typing your question, your name, and affiliation in the Q&A field. Once we begin the Q&A session in about 30 minutes, I'll do my best to take the questions in the order in which they're received. Now, to introduce NIA, we're a nonprofit, nonpartisan think and do tank, and our mission is to help create the conditions for success for advanced nuclear energy to play a major role as a climate and energy security solution. Our work focuses heavily on identifying gaps within the nuclear energy space and providing recommendations and solutions to bridge these gaps. Our latest report identifies and clarifies common misunderstandings regarding new nuclear project development. The report delineates what a project developer is, what their roles and responsibilities are, what challenges they may face, and what tools and methods are most effective for addressing these challenges. With growing interest in new nuclear energy deployment, as well as in restarting old nuclear plants, the need for clarity among nuclear project development stakeholders is greater than ever. Having clear expectations in terms of what roles are filled by who assumes financial risk, and what the stages of project development are will be crucial to deploying these clean, firm assets to meet climate and energy goals. And with that, let's get started. It's my pleasure to introduce report author and senior fellow at NIA, Steve Green. Steve is a former energy and finance executive with extensive experience in commercial and policy issues related to energy. His previous reports at NIA cover catalyzing early mover projects, due diligence for advanced nuclear energy companies, and ESG, or environment, social, and governance frameworks, and how they relate to advanced nuclear energy technologies and projects. I'll now hand it over to Steve to provide an overview of this new report. Take it away, Steve.
Thank you, Judy. So as we're all aware, there's growing interest now in nuclear energy as a source of carbon-free power that can be delivered 24/7 and sited near where the energy is needed. Recent transactions involving existing or restarting nuclear energy plants have made the news. Several advanced nuclear energy projects are moving ahead as public-private partnerships with the U.S. Department of Energy. However, many more projects are needed to meet climate goals and growing U.S. energy needs. Integrated electric utilities have discussed nuclear energy as an attractive option, but so far, U.S. utilities have not proposed specific projects, despite recent forecasts of more rapid electricity demand growth than we've experienced in decades. Some energy users have expressed interest in purchasing power from nuclear energy projects, but most have indicated they want to be customers of such projects, not developers. In that context, we looked at how energy projects are developed to provide some insight into the development process, what type of energy might serve as a project developer, what challenges they might face, and how those challenges can be met. Hack, you can go ahead to the next slide. A project developer is not playing the same role as a technology developer. While the technology developer is typically focused on maturing their technology so it's ready to be used in a commercial project, an energy project developer is typically working with technologies that are already commercially mature. Let's say typically. A project developer is focused on pulling together the many aspects of a potential project and managing the elements at risk to preserve the economics of an investment. Typically, integrated utilities have been the developers of nuclear energy projects, And that's in large part because most of that development took place decades ago, before there were as many approaches to energy project development as there are today. In principle, many parties could take on the responsibility of being a project developer, including utilities, industrial users, and independent developers, of whom there are now a few seeking to develop nuclear energy projects. Technology developers may also be project developers, either for an initial few projects or for the long run, but the two roles are different, and the parties need to be prepared for the different requirements and responsibilities. Zach, we can go to the next slide. Thank you. There may be a bit of a misconception about the role of a project developer in managing risk. Typically, project developers seek to manage risk and allocate it among project participants, assigning each risk to a party that can best manage it and has the financial resources to stand behind their obligations. Typically, project developers are not in a position to absorb the potential cost risk of early-stage nuclear energy projects. In a typical energy project, cost, timing, and performance risk is allocated to constructors and major equipment suppliers. But today, those entities don't yet have the experience with new nuclear energy technologies that would make them comfortable taking on those risks. Technology developers don't have the financial resources to backstop the risks, but that depends on the specifics of the project. In our view, risk management is the key issue hindering development of nuclear energy projects today. A key question is which parties have the motivation and the resources to take on that risk for the next few advanced nuclear energy projects. Next slide, please. In the near term, parties with the resources and motivation to support early stage nuclear energy development will need to help finance and help mitigate the financial risks. Utilities and states have commitments to decarbonize their power systems, and they recognize that renewables are a key source of power, but not sufficient by themselves. They're reticent to take on the risks of new major projects, but they need to balance that reticence against the risk that they won't be able to meet their clean energy commitments or indeed to manage their growing need for power. Groups of utilities could create consortia to build fleets of units, sharing the risk among many parties. If everyone stands on the sidelines, few projects will be built, and utilities will be challenged to meet their energy and climate commitments. Industrial users have decarbonization objectives and a critical need for firm zero carbon energy. The Amazon and Microsoft transactions, and even before that, Dow's start on a nuclear energy project, show strong interest among industrial users. Some industrial users like Dow have experience developing major infrastructure projects and may be willing to take on development risks. Others just want to be a customer. But industrial users, especially those who want to show climate leadership, may need to help take on some financial risk for early stage projects to catalyze the development of firm zero carbon power. For governments, deploying more nuclear energy production is critical to meeting decarbonization goals, as evidenced by DOE's call to triple nuclear energy production. Nuclear energy provides energy resilience, price stability, and security. For that reason, governments should consider mitigating part of the cost risk for early stage projects. Over time, we expect risk management for nuclear energy projects will become more like that of other energy projects, and development can become more straightforward. Next slide, please. Consistent with our previous work, in our paper, we suggest some approaches that parties can take to help project developers manage early stage project risks and accelerate development. For project developers, where applicable, they can bring efficient approaches from development of other energy projects to nuclear energy, as some parties are seeking to do. And they can improve their preparation for license applications to achieve an efficient licensing process. For private sector energy users, they can provide financial support for the development stage, and sponsors and off-takers can take on some part of the construction cost risk. And for the public sector, additional government support to backstop construction cost risk will provide the assurance that more project developers need to move forward on early stage projects. And we need to implement NRC reforms and consider other policy changes to reduce the cost of nuclear energy project development and licensing. Current NRC reform efforts in the ADVANCE Act are promising steps, but more actions should be considered. And so on that note, I'll turn the conversation back to Judy and look forward to hearing from our panelists. Thank you.
Thanks so much for that overview, Steve. I'm now pleased to introduce our two special guest speakers. As we've noted, there are significant challenges and opportunities in developing and deploying advanced nuclear reactors. Our two guests have unique insights into these challenges and opportunities, given their roles in helping to commercialize advanced nuclear energy as both technology developers and project developers. I'm going to first introduce both of our special guests and then let each of them talk in turn so as not to interrupt the flow of their conversation. I'll be back after both of our guests respond to get us started on the Q&A. And as a reminder, you're welcome to put questions in the Q&A. Just be sure to include your name and affiliation along with your question. Our first respondent is Jeff Miller. Jeff is the Senior Director of Business Development at TerraPower, developing relationships, new business alignments, strategic partnerships, and investment opportunities related to the Natrium project. He has more than 20 years of industry and government experience in nuclear power, including advocacy, business development, strategy, policy, program, and project management. Following Jeff's remarks, we'll hear from Craig Behlmer, Chief Financial Officer at Oklo. Craig has served as Oklo's CFO since August 2023. Craig also serves as an executive advisor to Trinden Consulting, a management consulting firm focused on supply chain management, primarily in the energy sector. Both Oklo and TerraPower are members of NIA's Industry Innovation Leadership Council, a collaborative forum for advanced reactor developers. The council wrestles with market and policy challenges, opportunities and solutions, informs NIA's strategy and activities, and better enables NIA and the advanced reactor community to articulate the conditions for success. The council provides input on NIA work streams, but it does not set NIA policy. And with that, I'll pass it over to Jeff.
Thank you, Judy. And first, on behalf of TerraPower, thank you for inviting us to participate in this important discussion on new nuclear project development. We would also like to congratulate the NIA on the publication of its paper on new nuclear project development, and in particular, Steve Green for his extensive research and authorship. The paper is very thoughtful and covers an important and emerging area of the new nuclear business model, namely project development. And the paper does this by analyzing and discussing systemic issues in need of resolution that currently hinder progress in building new nuclear projects. And we at TerraPower are pleased to see these issues highlighted so thoughtfully. It is true that in recent years, most utilities have not developed their own projects, and also that independent developers have not worked in the past to deploy a nuclear plant like they have for solar, wind, and gas. But just this past summer, TerraPower broke ground in Kemmerer, Wyoming, which marks the first new nuclear construction efforts since Vogtle 3 and 4. And we know, as Steve highlighted in his remarks, that nuclear power is necessary for grid security and carbon-free power, and further that nuclear will be a key technology to meet the growing energy demands in the coming years. But the nuclear industry has historically proven to be notoriously slow, expensive, and risk-averse, and the skill sets that are required for nuclear project development are considerable. However, it is important to keep in mind that basic development disciplines like permitting, offtake negotiation, debt and equity raising, and community relations are not new concepts. They can transfer seamlessly from other industries. The other thing to note is that development works when projects can isolate the key risks and assign each to worthy parties. And that said, the NIA report also addresses the fact that developers and the market in general are not ready to do this for new nuclear builds. So what this means practically is that if developers won't guarantee their design, and suppliers won't warranty their product, and a contractor won't wrap the EPC, in these cases, we have very large capital risks that are unmitigated. This places a drag on finance, and it also prevents debt from limiting its recourse, and it makes equity finance for early nuclear projects even more important. Turning now to some specifics on TerraPower that are relevant for this discussion. Kemmerer Unit 1 is powered by TerraPower's Natrium technology, and this is America's next reactor. We are a smaller scale advanced reactor, and that will cost significantly less to build. And this fact, in addition to other factors, makes us a more possible and flexible option, not only for deploying nuclear in the United States, but in many regions across the globe. And for our Kemmerer project, as Steve mentioned in his intro, we are partnering with the U.S. Department of Energy in its Advanced Reactor Demonstration Program, which is a public-private partnership. And our first unit in Wyoming, which is already under construction, will begin commercial operations in the early 2030s. And we're in the queue now with the US NRC for our construction permit, and we expect to have permission from the NRC to start nuclear construction in the second half of 2026. This is a project that will position TerraPower to contribute to stemming the impacts of climate change, lifting the developing world out of energy poverty, and strengthening our collective energy security, all core missions of TerraPower, in addition to improving global health. And it is important to note that for TerraPower and our investors, including our chairman and founder, Bill Gates, our first unit, which is a first of a kind or FOAK nuclear build, is 100% equity funded. We do not foresee the possibility of debt finance for our first unit or debt finance for FOAK units in general. Not only this, but TerraPower is also assuming the role of developer and technology provider for our first unit. We are also heavily involved in construction management and oversight. And the NIA paper, Nuclear Technology Vendors Assuming Developer and Technology Development Roles, was noted as one possible outcome. And it is important to note that at Kemmerer, TerraPower is undertaking significant project development activities, including investing in, coordinating, and executing a range of activities from site selection and control through licensing, engineering, and finance. And all of these activities are needed to position our first unit for construction and operations. So as a result, we have built considerable expertise in development. However, as the NIA paper rightly points out, nuclear vendors bringing technology to market need to decide whether they will continue to play that role for the long term or how we will extricate ourselves from that role for future projects. And looking toward the future, our inclination would be to focus on our strengths, allowing developers, which could be independent developers, industrial companies, or utilities, to focus on their strengths, while TerraPower focuses on providing our innovative nuclear technology to the market. Lastly, it is worth noting that allocation of risks are a significant challenge on first-of-a-kind projects. TerraPower sees a bright future for new nuclear in the coming decades, and of course, specifically Natrium. Based on our client interactions and our competitive analyses conducted around our technology, we also see a significant total addressable market for Natrium in the 2030s and beyond for our sodium-cooled, low-pressure nuclear reactor and our thermal energy storage system, which, with our fast electrical ramp time, can help smooth variability on the grid and provide significant resiliency benefits as well. The more we can introduce our reactor in the United States and globally, the more we can incorporate construction and operations learning and supply chain efficiencies as well through multi-unit orders. And returning to Kemmerer Unit 1, TerraPower is shouldering significant risk in order to bring this FOAK technology to market. However, we expect allocations of risk among project participants will become more efficient as we scale our technology in the 2030s and reach our nth-of-a-kind configuration by the middle of the next decade. I appreciate you listening. This concludes my remarks, and I look forward to our discussion.
Jeff, those were great remarks. Oklo would also like to thank the NIA for the opportunity to be on this panel and present in conjunction with TerraPower. Oklo is developing the next generation of nuclear power plants focused on providing reliable, affordable, and clean energy. We offer both 15 and 50 megawatt power plants built on the mature legacy of liquid metal sodium fast reactor technology, specifically used at the experimental Breeder Reactor 2 in Idaho. Our approach centers on three key pillars that we believe will drive significant change and opportunity in the industry: a new business model, rethinking reactor size, and leveraging proven best-in-class technology. I'll now discuss each of these in a bit more detail. Business model. As the company was being formed, we saw a substantial appetite for the advantages nuclear energy can provide. That insight led us to a model where, like the renewable energy sector, we design, build, and operate the plants ourselves while selling power through power purchase agreements, or PPAs. This model gives us control over the full value chain and allows customers to benefit from nuclear's reliability without taking on board the burden of ownership. Reactor size. Second, we wanted to take a different angle on size. Instead of starting with large, capital-intensive projects, we opted to begin with smaller reactors. We have found a sweet spot at the 15 megawatt and 50 megawatt reactor size, with the potential for 100 megawatts as we scale. This approach makes sense as our reactors are more accessible to a wide range of customers and markets and drastically reduce upfront capital requirements, which helps accelerate deployment. Technology. Third, our technology, like TerraPower, is based on a best-in-class sodium-cooled fast reactor, a proven system with a long development history. We utilize liquid sodium as the coolant because of its advantages. It operates at high temperature without being pressurized. It is compatible with common alloys and enables us to maximize the use of materials, parts, and labor from non-nuclear supply chains. The ability to utilize supply chain components allows us to operate at a much higher volume and offer more diverse options that come at lower cost. This drastically reduces cost and enhances economies of scale. Our technology builds on the legacy of EBR-II reactor, which demonstrated amazing features from both an inherent and passive safety perspective that enables plant design simplification and therefore cost reduction. In addition, our plants can operate on recycled fuel, which will be the case for our first facility at the Idaho National Labs. Additionally, the Nuclear Regulatory Commission, or NRC, has experience with sodium fast reactors, giving us confidence in our regulatory pathway. I'd now like to give an example around how we're putting this to use around project execution with the deal that we've announced with Siemens Energy. Given today's topic, it really is a great example of how these things come together in terms of business model, size, and technology. Our recently announced preferred supplier agreement with Siemens Energy, who will supply steam turbine generators, or STGs, for our fleet of powerhouses, allows us to use an existing STG produced by Siemens today and used in other industries. The size of that STG allows for transport by rail or truck. Our business model means we will be sourcing many STGs from Siemens, allowing our revenue growth to be revenue growth for Siemens Energy, as well as enabling purchasing economies of scale. Currently, we are advancing our engagement with the NRC through white papers and pre-application meetings in several topic areas. We're pursuing a streamlined approval process underpinned by our combined license application that benefits from our years of regulatory experience with the NRC. Earlier this year, Oklo completed a business combination with AltC, becoming a publicly traded company on May 10th. This has resulted in a well-capitalized balance sheet, providing over $300 million in gross proceeds, positioning us to effectively execute our strategy. At the time of our merger, we announced over 700 megawatts of signed agreements through Memoranda of Understanding, MOUs, and Letters of Intent, or LOIs. Since then, we've expanded our partnerships, including deals with Equinix, Wyoming Hyperscale, and Diamondback Energy, bringing the total commitment to nearly 1.4 gigawatts across multiple sectors. I'll now turn the microphone back to Judy.
Thanks so much, Jeff and Craig, for these terrific insights. We're now going to turn to the Q&A, and we actually have a bunch. As a reminder, please include your name and affiliation, as well as your question. So the first question I see is, it's a long one, from Dan Yerman at Neutron Bytes. Costs for new reactors and the 1,000 megawatt size, such as Vogtle, will only come down if the U.S. commits to building them by the dozen, for example, in fleet mode. Such a commitment will bring supply chain costs down and make them reliable, create and sustain an experienced labor force, and speed up regulatory reviews, assuming the builds are PWRs and not advanced designs. India has taken this approach with plans to build a fleet of 10 now and 7 more later of their domestic PHWR CANDU type 700 megawatt reactors entirely supported by domestic suppliers and labor. This will be followed by a fleet of scaled down PWHRs at 220 megawatts, which will be a much better match for some parts of India's electricity grid and put more power in more places sooner. What are the prospects for building new reactors of any size or design in fleet mode to achieve similar benefits? Anybody want to volunteer for that one?
Judy,
Okay.
I'll start. I think part of our business model is actually to deploy fleets of asset at that 15 and that 50 megawatt scale. And I talked a little bit in my opening remarks about data center growth or about the growth in our order book. Most of that has come from data center customers, and they're actually interested in buying, more than one 50 megawatt reactor that will be deployed in bulk at a data center's campus. What we like about that from an asset deployment point of view is we believe over time our time to deployment and our cost to deployment will come down as we're able to take scale economies and learning curve effects and apply that from the deployment. The other thing that the data center customers like about this is typically a greenfield data center campus is not built overnight. It's built in stages, and we can deploy assets, in stages as the data center park grows. So I think there is the opportunity, but I agree with kind of the question or the comment within the question that, the more you can deploy something at scale, the more you can deploy something at bulk, through that repetition, there should be the opportunity for learning curve effects that should reduce time to deployment and cost of deployment, as you get better at it.
Great. Jeff or Steve, do you want to weigh in on that one as well?
Well, I would just add just one or two things. First of all, just to make sure that we're all level setting to the same information, advanced generation is here right now. We could scale advanced generation. That can be a sodium reactor or another generation 4 technology in the same way that we can scale and have scaled light water reactors. And that is exactly what TerraPower is focused on, not only from the regulatory perspective in our discussions with the NRC, but with discussions with myriad customers that range from industrial to data centers to utilities. We will demonstrate and scale in the United States as our first priority, and we will do that not only on the West Coast, but on the East Coast, and a number of discussions are pointing toward that right now. And as Craig said, the more we can get out there, the more we can bring down our levelized cost of electricity and also our costs for supply chain and construction. And we've done a significant amount of analysis on ourselves and our competitors, so we very much understand where we sit in the market relative to nuclear and non-nuclear technologies alike, and what we need to do to scale, and what the economics will look like as we go down the cost curve. Thank you.
Thanks. Steve, do you want to weigh in on that one?
I'll just add briefly, I think there's tremendous interest in the US in deploying fleets of nuclear technologies. I think there are a lot of parties kind of looking at the benefits of doing that, which do get you to sharing risks and moving down the learning curve. But I also think one aspect of Dan's example is important, which is the government is behind the deployment, and I think in the near term, that could really stimulate. I think if the government stepped in and said, yeah, if you are willing to build a fleet, then I'm willing to help cover some of the risk of the cost. I think we get a lot of people on board very quickly.
Thanks so much. The next one is from Doug Vine. He says commercial banks and venture capitalists expressed a desire to support and fund new nuclear at Climate Week last week in New York City. Which risks are they most concerned about seeing resolved so that they can fully participate in financing more of these clean energy projects? And that's from Doug Vine of C2ES. Who wants to take that one?
I can start, Judy.
Oh, go ahead, Steve.
Yeah. I think it was wonderful to see that announcement. I think it really represents the light going off, I guess, so it's poor pun, in, on the part of banks, with an indication that nuclear has now, nuclear energy now has risen to the level of interest for in the financial community. I think in terms of the risks that need to be resolved, I think it was great to see the commercial banks be part of that commitment. But now the rubber meets the road, and the question is, well, what do the actual transactions look like? And I think right now we're in the early stages of the technology deployment, and I think there is going to, when we get to actual transactions, it may be difficult for the commercial banks to move forward unless there's a party able to step up and cover risk. I think they'll participate, but I think they're going to be looking to take a position where they're seeing somebody else in the lead and taking on the bulk of the risk. And the question is, who's able to step into that position?
Craig or Jeff, do you
Judy,
want?
maybe one thing I can add to it. I think we've already had a great example for the sector around how much interest there is in nuclear, which was the success of our de-SPAC transaction in May. That when you do a de-SPAC, the owners in the SPAC have a choice of either taking their cash back, which is called a redemption, or taking shares in the company. Typical de-SPACs can have 25 or 50% redemption. Oklo had 0.002% redemptions, which meant all of that cash in the trust, the shareholders converted almost everything into Oklo shares, and Oklo got that cash to grow our business. And I think that's a great example of investor interest in nuclear and how far the industry has evolved and is evolving. When I'm talking to potential future investors, I think the questions are around, they do want to understand what our regulatory pathway is. They want to understand, and I've seen some of the questions around what's out there in terms of the ADVANCE Act or other motivators to actually reduce those regulatory timelines. There's an education piece about the business and the business model. And the other thing that I think is going to be important for us, because long term we want to use project financing to finance against our power purchase arrangements. I think the question there is going to be, how long will we need the first plant or the first couple of powerhouses to operate to be able to demonstrate a reliability track record that'll give a lender the confidence to lend against that PPA.
I would just add one or two things, Judy, which is simply that if you put yourself in the shoes of banks or others, as Steve was highlighting, you could look at regulatory risk, design risk, construction risk, and performance risk, probably like 4 broad categories. And those are things that are unknowns on first of a kind projects. I mean, of course, developers like us and Craig are working, in those areas to bring greater comfort to the market. But it's not surprising that most banks and other potential sources of financing would be very risk averse relative to those 4 categories until they see some progress and at least a reference plan. Thank you.
Right. So next question I see is Adrian Cantwell. He says, in terms of regulations and construction issues, can anything useful be learned from how other countries overcome problems? Anybody want to take that on?
So maybe I've only worked for Oklo for 14 months, so maybe I'll do this as the newbie in the conversation. I think that we have got great nuclear capability in the United States. Where I'm envious of other countries is it appears to me that they've stuck with it. And they've stuck with it over the long haul. And I think that has benefits to regulatory approval. I think it's got benefits to deployment. I think it's got benefits to the impression that the public has around the sector. So, I mean, we're I think at a tipping point for nuclear. If I had jumped on this call a month ago and said, hey, I bet 3 Mile Island's going to be restarted and they're going to make an announcement on it, Judy, you probably wouldn't have wanted me to participate. So I think there is a change afoot, and I think it's a great generational opportunity for us. But there's going to be bumps along the road, and I think the trick's going to be, fix the bumps, move around the bumps, don't get distracted by it, and stay on course and stay on path.
Yeah. I would
Yeah.
just add one thing, which is for our program, we do look in terms of benchmarking at how other countries handle community relations, stakeholder relations. I think it's very important to look at that. On top of that, we do look at how other countries and specifically foreign utilities have handled startup protocols, especially early on in their nuclear programs. Like, what did they do? How long did it take? What meaning does that have for us? And how can we sort of make assumptions on our startup timeline and then significantly shorten that as we get more experiences under our belt with subsequent deployments?
Right. Steve.
Yeah, I would just say my expectation is that everyone that is developing and especially constructing these projects is going to pay attention to lessons learned wherever they can get them. I think people have paid attention to how efficiently Barakah was constructed in the UAE and how that was accomplished. I think people have taken lessons from the Vogtle process, both the things you should do and the things you shouldn't do. And I think actually, there's a tremendous amount of attention to what's going on there. And I think a lot of people are paying attention to what Ontario Power Generation is doing, how they're deploying that project. You can look at the cooperation agreement that TVA has with OPG and, realize that everybody that's getting into this business is trying to pay attention to whatever successes have come along.
Great, thanks. The next one is from Aaron Larson from Power Magazine. Assuming FOAK units or first of a kind units are deployed successfully, how do TerraPower and Oklo envision the supply chain evolving for each of their technologies? Would each of your companies be building one large manufacturing facility that would effectively become the site where units are built and shipped from? Have sites like for this been identified? How long do you expect it to take to ramp up and produce significant output from such a facility? Do the capabilities exist to build all components in the US, or will your companies be forced to rely on suppliers in China and elsewhere? That was a lot of questions, so pick parts of it if you can. And either of you want to take that on? Go ahead, Craig.
Well, I touched a little bit on the Siemens Energy preferred supplier arrangement, and so that's one example of our supply chain strategy is, anywhere where we can source something from an existing supply chain, we think that's a great way to enhance our ability to deploy assets. And there's some other elements that, there's some other things that we're looking at the moment. It's commercially sensitive, so I'm not at liberty to talk about it, but we'd like to do more of the great partnership we've done with Siemens. And they do like the fact that, if our growing order book can become their growing order book as well, which I think creates a win-win. There's another bit of the project, as we move from those first of a kind deployments to multiple deployments, one of the things that we will look to figure out is what are the sort of things that we could do at one center or manufacturing hub and do things centrally, and then deploy those components to our various sites for our powerhouses. I think our watch point there is we know we're going to learn some things through those first couple of deployments. So it's a little bit of don't rush in on the first one and just give yourself a little bit of time to learn so you can determine what are the things that could be done at a manufacturing hub and what are the things that need to be done at each site deployment. And then I think there was a third element around ITCs. That is something that we do want to leverage at Oklo. There's a 30% of an ITC that's available for just our type of energy projects. My understanding, there's another 10% that's available if it's part of an energy community deployment, so a pre-existing site, which I think probably has more applicability to TerraPower. And then there's a third 10%, which is, can you demonstrate that you've maximized domestic content in the asset you deployed? And I think that's going to, that 10% is going to encourage us to try to find domestic supply chains as we source goods and services, and maybe encourage the creation of domestic supply chains as well.
Yeah. I'll just say for TerraPower, we have two sides of our plant. Ostensibly, we have the nuclear island and our energy island. We are at TerraPower directly managing our nuclear island component procurements. And we have more than 80% of our nuclear island already awarded under contract, although not announced, but I would expect some announcements to come out before the end of the year. It is a mix of US and foreign suppliers. That's a function of capability, pricing, and other factors. And right now we are having discussions with our supply chain about how to scale into 2030s with baseline assumptions about a certain number of reactors per year based on the interest that we're seeing in our technology from the market. I would not say at this moment in time we're thinking of centralizing, although we could potentially consider something like that in the future. Thank you.
Great.
Judy, can I add one other thing? One
Sure.
thing we've had some discussions with a few customers about is, the data center provider is going to need to source steel, cement. They're going to need to have EPCs on site for their deployment. So one of the other conversations that we're starting to have with some of our customers is, are there things that we can leverage with what they're already having to do at the industrial park or the data center campus as well? So, and I think it's an incentive for them because, the reason they're talking to us in the first place is, they need the power to run their business. So anything that they can do to help us be successful just gets them the power they're needing. And I think that's another avenue that we can go down to help de-risk our projects as well.
Great, thanks. This next one is from Matt Wald from Breakthrough Institute. He asks, when non-utilities step in as developers, do they face a steeper climb at the Nuclear Regulatory Commission because they have no previous experience in the field? Anybody want to take that one? I guess, oh, go ahead.
Yeah, Judy, if you want to take it, go ahead.
Yeah, I'll help everybody out. So we've found a couple of things. One of the things that we said in an earlier report on due diligence for advanced nuclear investments, that just as with any technology company, you have to look at the technology strategy and the business strategy for a company. With an advanced nuclear company, you also have to look at their licensing strategy. And we have found that there are a range of different approaches to the Nuclear Regulatory Commission. And while nuclear experience with earlier technologies can be helpful, and certainly understanding the licensing process is helpful as well, often newer players can bring more innovative approaches to the licensing process. And particularly for these first movers or early movers, having a innovative approach on both the part of the license applicant and the Nuclear Regulatory Commission is really going to help us succeed, because both the Nuclear Regulatory Commission and these early mover project developers are having to find flexibility in existing rules that have evolved to really be more tailored to more conventional technologies. So you do need that nuclear experience, but you also need this kind of regulatory innovation. So we see that both can be super valuable. While I was filibustering there, anybody else want to chime in?
Judy, I'll just add, part of the process is discipline in terms of both the development process, getting all your technical work done, and going and discipline with regard to your approach to licensing. And so, somebody like that who you mentioned, I mean, they have a lot of experience developing infrastructure in some very complex environments. Now, they don't necessarily have the nuclear knowledge. They're going to rely on X-energy for some of the specifics of the nuclear knowledge, but you better believe they're going to be organized with regard to how they approach, the licensing process, and they make sure they have their ducks in a row. And I think that that's a big aspect of how you approach licensing.
Great. Okay. Let's see, the next one also, Adrian Cantwell, please expand on the NRC reforms you'd like to see and how likely it is that such reforms will be implemented. I guess I'll start us off on this one as well. We have a little paper called The Urgency of NRC Reform. I don't know if we're able to put links in the chat, but if we can, maybe somebody on our team can do that. And that also, it's like a 2-pager, and it has links to a bunch of our work on this. And this is NIA's work on NRC reform. We see needs on 3 timescales. One, the early mover that I just mentioned, which is kind of like one-off regulatory innovation, which is essentially a collaborative effort between good applicants and good NRC. And so that's something that's happening even as we speak, and it has to work out to find innovative approaches under existing rules. The second timescale is in the midterm, where there's a new rule under development at the Nuclear Regulatory Commission called Part 53, and that rule is going to be more flexible inherently than the existing rules, and should be better tailored to allow this new generation of technologies to get licensed without having to do exemptions and without having to do this sort of more one-off regulatory innovation. And that rule is under development even as we speak. And then the third timescale we see is the long term, where what we call high volume licensing is what we're hoping that we get to. And that's a process. First we have to go through the innovative process that we're going through now. Eventually there'll be a down selection, at least not, we still think there's room for several designs under several use cases, but we probably will have only a few designs ultimately. And then that will take standardization once we've settled on a few designs, both on the part of the industry as well as on NRC, because they will be more able to license things in a high volume manner if they're standardized. And so we see in a future where we have lots of demand and supply of new nuclear projects that will be able to get much faster and be able to do this at high volume, but that's in the longer run. I don't know if anybody else wants to comment on that one. Great.
I just think anything that encourages pace and anything that encourages collaboration is is a win-win. And so I think the Advance Act was a good, positive step in the right direction. It's just let's not use that as we're done. Let's use that as that's a great achievement, and let's keep going.
Great. Okay, let's see. We actually have a few more. I hope I'll be able to get to all of them. You touched on this a little bit, Craig. This questioner asks, how will the investment tax credit shape deployment interest in the U.S.? And I think you were speaking about it more on the supply chain. Can you also speak to it on the reactors, either you or Jeff, or maybe Steve?
So part of our overall strategy is that, we in turn intend to leverage ITCs. We believe that there should be ITC, in that, we think for us, probably in that 30 to 40% range, that would be available to Oklo once we start up an asset. That would cover 30 to 40% of our asset costs and our fuel costs. And so, that's a great thing to help our cash flow. Now, the de-SPAC left us, well capitalized to deploy our first couple of assets. And Jeff's already talked about, the challenge, but the goodness of being able to equity finance. But it's nice for us to have the cash flow that would come in from the ITCs. And, and I think we see that as also something that over time creates a great opportunity to lower our overall levelized cost of energy, which is great to making nuclear competitive versus other renewable alternatives.
Jeff, go ahead.
Just to note that we're also intending to utilize the ITC for sure, as somewhere between 30 to 50%, depending on factors and locations. But we would also at some point be advocating for an extension of of those tax credits right beyond 2032 or 2033, whenever I think the sunset might be. Thank you.
Great. Steve?
Yeah, I just wanted to point out that, first of all, the availability of ITCs to nuclear deployment is in and of itself a huge step. Under the IRA, finally put the nuclear energy on a kind of equal footing with other types of zero carbon energy. And I think the ITCs, as both Jeff and Craig have mentioned, I mean, they are really significant in terms of helping address the risk issues that developers face and sponsors to this face. So they are big for us, as Jeff said. We're probably not on the right time frame for them. They probably need to go on longer, but I think they will be a good influence towards deployment. But as we've talked about, at least for the first few projects, they're probably also not enough. So that's a big aspect of that was priority.
Great. And this is sort of related. Another question is, how do we get legislators to be as open to nuclear energy as renewable? And I would say that the enactment of the ITC and actually a whole bunch of policy that we've been enacting at the federal level over the past few years is demonstrating that there is growing support for advanced nuclear energy, both as a climate solution and an energy security solution, and the enactment of these tax credits, the investment tax credit, as well as the production tax credit, and a whole bunch of other policies like funding the Advanced Reactor Demonstration Program. Oklo recently announced a partnership with, I believe, INL, the Idaho National Laboratory. So there is a lot of federal policy and investment that's getting enacted, and that's moving the sector forward. And of course, it has to be done in partnership with the private sector. That is historically how we in the U.S. make progress in the energy field, is that it's a mix of public and private actions, and they're mutually reinforcing, and we get the benefit of the commercial side, understanding what will really work in the marketplace, and the benefit of the federal side, making sure that they buy down the risk in the beginning in the public interest. Anybody want to comment on this one?
Just, Judy, I would note that the Department of Energy has given us fuel and land for our first deployment at the Idaho National Labs. And we are also doing a lot of work on fuel recycling technology. And most of that work is actually being done at the Argonne National Labs just outside of Chicago. So I think, anything that you can do like that, where you're doing it in conjunction with the Department of Energy, I think creates a real win-win on, for the sector and everyone who's wanting what we're trying to provide as an offer overall.
Go ahead, Steve.
Yeah, Judy, I just want to say, as you said, look, there's already been government expression of interest in nuclear energy. First of all, through the ARDP program that both Oklo and TerraPower are part of. I think Oklo, right? Maybe I have that wrong, but and through the IRA. But I also think, stepping back into how we got started in zero carbon energy, look back 20 years ago, there needs to be, a recognition that when you're in the early stages of technology deployment, you need a significant amount of support. We gave that to wind and solar energy, 20, 25 years ago. It probably, needs to be applied to nuclear energy today. And I think, turning to the states, there needs to be a recognition that, for all those states that have, decarbonization objectives, nuclear energy has to be part of that. And yes, is it going to take, is it going to imply some risk on behalf of, state governments or regulatory agencies possibly, but if you really want to move forward, have the zero carbon energy and have enough energy to supply data centers and all the other growth we have, you need to, put some support behind it.
Right. Jeff, did you want to add anything?
Nothing at this time. Thank you, Judy.
Great. So I think this is probably our last section, last question. What can you say about your customers? Is that evolving? What do they need? What are their timeframes? How do you see your customers and I guess overall demand for your products changing even as we speak?
Well, I'll start, I guess. So for us, we're having significant discussions with a wide range of customers, utilities, data centers, obviously, industrial customers, of different verticals, including chemical and oil and gas and others. And some of the discussions we're having are related to heat because we can provide power and heat from our reactor, and some are related to electricity or the electrification of certain industrial processes, which requires electricity. And we are working on our order book right now. We are a 2030s technology, early 2030s. Most of our customers would like us to be there before 2030, but that's not us, and I don't think that's most advanced nuclear developers either, although Craig can tell us his timeline. So we would expect some announcements next year on our order book, and that's about what I could say at this moment in response to that question. Thank you.
Yeah,
Craig?
so similar to Jeff, we're looking to sell power in the data center space, industrial, oil and gas, military, and master plan community, so like a subdivision and a business park. And we've announced something in each one of those sectors with the exception of master plan community. When I joined Oklo 14 months ago, the order book was sitting at 700 megawatts. And it was mostly customers who wanted 15 megawatt powerhouses, and they were probably looking for the deployment of one powerhouse per location. In the last 14 months, that order book has doubled to almost 1.4 gigawatts. Most of that growth has been in the data center space, but not all of it. And it's now customers who are wanting more 50 megawatt facilities and potentially more than one powerhouse per location. So I think that size is a great example of evolving. And I think similar to Jeff, I somewhat joke, but I'm also being serious that prior to Oklo, I worked 28 years for BP and then 2 years for a company called Renewable Energy Group, which was the largest producer of biodiesel and renewable diesel in the United States. It's only taken me 30 years in the energy sector to actually find a product and an offer that my customers want to buy. No one ever wanted to buy gasoline or jet, or diesel, but there's huge appetite for people wanting what both Oklo and TerraPower is looking to provide, which is clean, affordable, reliable energy. And I think the biggest question we all get is, can you move faster? And I think we're all starting to get questions of what can we do to help you move faster, which I think is a great place for the industry to be.
Jeff, you want to add anything?
No, well said. That's what I could say. Well said, Craig. Thank you.
Steve?
There's nothing that I can really add on customers and actual customers for these folks. I think there are a lot of potential customers. You see it all the time, and you see people with very creative we'll say interest in some of these products. It's going to take getting the first few of them online, and that's a little bit bigger hurdle, but once they're moving along, I think there's huge potential.
Great. Well, I hate to put a stop to this great conversation, but we're approaching the end of the hour. I want to thank Steve Green for his work on this new NIA report, and much appreciation to TerraPower's Jeff Miller and Oklo's Craig Behlmer for joining us for today's conversation. On behalf of the entire NIA team, thank you all for joining us today. We look forward to seeing you here for our next NIA briefing. Stay tuned for your invitations and more information on our upcoming publication schedule and updates. Thanks all.
Cool. Thank you very much.
Thank you.